So here we have page 129, number 1. They want you to express this 2 and 60 degree using different polar coordinate notation. Alright, so 2 and 60 is over here. 2 length. Okay, we said before, even if I come around, it's same, right? So it's like 2 and 360 plus 60 is okay too. Or the other way around is okay too. So 2 and minus 300 is fine too, right? It's the other way around. Or in this case, we could make this opposite angle here, right there, where this is 60, so that I can point minus direction so that I would end up in the same direction. So I could do minus 2, where the angle is on the other side. So it's like 180 plus 60, so that's going to be 240. Minus 2 and 240. Do I have that there? Yes, we do. A is the choice. Okay, that's how we can change it. So go back here, go here, but it's minus direction, so we go to the other side. Okay, let's do number 2. This one has a 2 and 200 degree polar coordinates. Of course, this is r, this is theta. They want you to express this in terms of rectangular coordinates, which is x and y. So how do we express this to x and y? Well, we just need to remember that x in terms of r and theta is r cosine theta, and y is equal to r sine theta. That's all that is. So we can just fill it in. R is 2, theta is 200. And here comes your calculator. So what do we get for cosine? We get everything together minus 1.88. And the other one, we get minus 0.68. So we end up with choice A. Good. Minus 1.88 minus 0.68. We get A choice. Good. That's it for that. All right. Describe the graph of R 3 over cosine theta. That's really easy. R is equal to 3 over cosine theta. Well, we know that x is in terms of theta and r this way. R times cosine theta. But r is expressed such way, so I could change that to 3 over cosine theta times cosine theta is equal to 3, which means x is equal to 3. What kind of stuff is that? It's a vertical line that goes through 1, 2, 3 over here. Good. Done, done, done. All right, let's go to page 133. Number 1, we're talking about three-dimensional geometry. Okay, so we have a right circular cylinder inscribed in a cube. Cube is all three sides are same. So we have this kind of picture. Everything is x here. X, x, x. And we have a cylinder that is inscribed that way and with the bottom attached to it as well. Okay, something like that, right? Okay, so we realize that the radius or the diameter is same as this side, right? X, which is the radius makes x over 2. Good. They want the ratio of the volume of cylinder to the volume of the cube. So we will get the cube first. Cube volume is, well, x times x times x, right? So it's going to be x cubed. Good. Cylinder has a base area times the height. Height. Okay, base area is pi r squared, right? Pi times r is x over 2 that we just found. Multiply by the height. What is height of this cylinder? Same as the cube, which is x. So put them together, I get pi over 4 times x cubed. That's my cylinder. Okay, what is the ratio between that to that? So cylinder comes first, right? So cylinder 2 cubed is pi over 4 x cubed 2 x cubed, which makes this thing pi over 4 to 1. Okay. So the ratio, you can also express it as that to that is that over that, right? We can make it into fraction. So it's going to be pi over 4 over 1, which is pi over 4. Here's another.